Hello, statisticians. I'm stealing Mr. Youngsaber's intro again. These are our solutions for Can You Do 53. I'm gonna go through them. I'm gonna try to go through them a little bit quicker, just so that I'm not wasting any of your guys' time. Because of that, if I'm not explaining things thoroughly enough, please make sure that you make a little note, star it, highlight the problem, and then when I see you in class, you can ask the questions that you need clarified. If you're one of my distance learners, then maybe take a video of yourself asking your question, and then I can reply by answering your question doing this, like with my doc viewer and stuff. Okay. So number one, suppose your job at a potato chip factory is to check each shipment of potatoes for quality assurance. Further, suppose that a truckload of potatoes contains 95% that are acceptable. If more than 10% are found to be unacceptable in a random sample, you must reject the shipment. To check, you randomly select 250 potatoes. Let P hat be the sample proportion of unacceptable potatoes. Okay, so our population data is that 95% of our potatoes will be acceptable. So suppose that a truckload of potatoes contains 95% that are acceptable. That means that for any given truckload of potatoes, the percent that are unacceptable is 5%. If 95 are, then 5 are not. Okay, what is the mean of your sampling distribution? So P hat is the proportion of unacceptable potatoes. So they clearly give us the amount that are acceptable. They tell us that they want the P hat to be the ones that are not acceptable. Our mu sub P hat is equal to P is equal to the 5% because we randomly selected the 250 potatoes that we're going to test. Check the 10% condition and calculate the standard deviation of the sampling distribution. So plugging that into our formula, P is 5%, 1 minus P is 95%, and our sample size is the randomly selected 250 potatoes. This gives us a standard deviation of 0.0138. And then I'm explaining we can calculate this because it is likely that there are more than 2,500 potatoes in the shipment. So 250 potatoes is less than or equal to 1/10 of the population. Where did I get this 2,500? Well, remember that saying n is less than or equal to 1/10 of the population is the same as saying 10 times n must be less than or equal to the population. Well, 10 times n is equal to 2,500 potatoes. And in a big semi-diesel of potatoes, I definitely think there are more than 2,500 potatoes. So I personally think that capital N is 2,500 plus. It's more than that. Check the normal condition and sketch the sampling distribution of P hat. So let's start there. Check the normal condition, that means check large counts. The first one is satisfied, n times P. The second one is satisfied, n times 1 minus P. So sketch the normal curve, and this goes back to Unit 3, Unit 2, Unit 3, where we actually have to draw the normal curve and write the sigmas down. So I have the name of my normal curve. It has a mean of 0.05 and a standard deviation of 0.0138. So down here I have my mean in the middle, and then I have written the proportion for 3 sigmas above and 3 sigmas below. So that's this part. Check the normal condition and sketch the sampling distribution of P. This is the sampling distribution of P. Notice that it's centered at the true value. Based on our sketch, do you think it would be likely to reject the truckload based on the random sample of 250 potatoes? So remember, we reject at 10%. Okay? Well, do you think it would be likely to reject? Well, how many of our shipments contain 10% or more unacceptable potatoes? Well, look at your normal distribution. The highest we go, the third standard deviation, is 0.0914. So 10% would be somewhere out here. And based off of our knowledge of the normal curve, we know that the percent of data that is more than 3 standard deviations away is very small. It's 0.15%. So remember, we have that this is 68%, so 34, and then this is 95%. 13.5, 13.5, and then this is 2.35%. And on each end is that very little amount of data. So based off of our distribution, what percentage of the time does our truckload have 10% of potatoes that are unacceptable? Not very many, less than 1% of the time. So it would be very unlikely, less than that little bit of percent that is beyond the third standard deviation, to reject the truckload, because a p hat of 0.10 is more than 3 standard deviations away from the mean of 5. So very unlikely. And this is a good review problem just in general of normal curves. Okay, number 2, attitudes towards shopping. A sample survey shows that fewer people enjoy shopping in stores than in the past. We ask a random sample of 2,500 U.S. adults. In this survey, 1,575 agree that they prefer to shop for clothes online. A manager at a local clothing store claims that 60% of adults would say agree. What is the sample proportion of U.S. adults that agreed with the statement? 1,575 out of 2,500, so 0.63. If the manager's claim is true, what is the probability that we would get a sample of 0.60? So at least as far above 0.60 as the results of this survey. Let me read that one more time. If the manager's claim is true, what is the probability that the proportion in a random sample of 2,500 adults is at least as far above 0.60 as the results in this survey? At least as far above. So it can be that far above or more. Okay? So our manager's claim is 60%. We want to find the probability that we would get a sample proportion as high or higher than the one we got. So we're looking at 0.63 and higher. All right, well, our sampling distribution is normal. with a center at the claimed value and a standard deviation that can be calculated. I check my large counts here. My sample was random, and I personally think that 2,500 is less than 1/10 of all U.S. adults. There are millions of U.S. adults. Millions. So 2,500 is definitely less than 1/10 of a million. They are asking us to calculate the probability that we would get a sample as high or higher than ours. Well, that's the same as getting a z-value of 3.06 or higher. This is how I calculated my z. Well, we know that if we want to calculate the area to the right of a curve, we have to do 1 minus the area to the left. So I get a very small percent, or a very small probability, 0.0011. And then just like I did in the notes, I'm going to answer this with a formal statement. The probability of getting a sample proportion of 0.63 or higher is about 0.11%. And you can leave it there. You don't have to say if 60% of all U.S. adults agree with this statement. You can just leave it here at 0.11%. Based on your answer in Part B, do you have a reason to doubt the manager's claim? Yes, because if 60% agree with the statement, the chances we would get a sample result that we like ours is less than 1%. That's way less than 5%. Remember, our cutoff is 5%. This happens less than 1% of the time. So yes, I doubt the manager's claim. There is convincing evidence against the claim that 60% of all U.S. adults agree with the statement. It is not plausible to get a sample of 63% if 60% truly agree. Okay, so I just want to recap the answer for Part C. Notice that I'm using the word plausible. So it is possible to get a sample value this low, but it's not plausible. It's more likely that the claim is not true than we were just unlucky enough to get a sample value of 63 or higher. So we doubt the manager's claim because if his claim is true, the probability that we would get the sample that we got is less than 1%. That's way too low. Okay, next problem, on-time shipping. A mail order company advertises that it ships 90% of its orders within 3 working days. You take an SRS of 100 out of the 5,000 orders received in the past week. The audit reveals that 86% of the orders were shipped on time. If the company really ships at 90%, what is the probability that we would have gotten the sample that we got? And then show your work just means check your conditions. So our sample comes from a population that is normally distributed because the large counts is satisfied. The mean is the same as the true population value, which is 90%. That is true because an SRS of 100 orders was taken. And then lastly, we can calculate our standard deviation. I get 0.03. And that is because the 10% condition is satisfied. And we can check that for sure because this is N. And we know that big N is 5,000. Our sample is 100. Our population was 5,000. So this is the statement asking, what is the probability that we would get a sample that is less than or equal to 86% shipped on time? Well, that is the same as the probability of the z-score being less than or equal to negative 1.33. And that gives us a probability of about 9%. The probability that the proportion of orders shipped on time will be 86% or less is 9.18%. So it's low. It's not common that that would happen, but we wouldn't reject this claim. They claim they ship 90% on time. This sample doesn't give us any reason to question that claim because it happened 9% of the time. Okay, number 4 is like one that we haven't seen before. So if this one stumped you a little bit, that's completely reasonable. If I get to the to the part that probably confused you and you feel like you can do it, I would pause the video, finish it, and then watch my solutions. So phone company is interested in exploring marketing possibilities for a new smartphone for teenagers. They take an SRS of 1,000 high school students, whether they own a smartphone. Okay, I gotta read that sentence again. They ask an SRS of 1,000 high school students whether they own a smartphone. Okay, that makes more sense now. Suppose that 65% of all high school students own a smartphone. So that is our P. Suppose that 65% own a smartphone. What is the probability that a randomly selected sample will result in a p-hat, so a sample value within 3 percentage points of the true population proportion? And that is the portion that I thought might give you guys some trouble, this within 3 percentage points. So let's just start what we know. If you haven't already written out what the distribution would look like, do that, because you can do that without understanding this 3 percentage points business. So our sampling distribution is normal because the large counts is met. The center is at the true value because an SRS was taken. And I think that 1,000 is less than 1/10 of all high school students. Like 1,000 is probably 1/10 of all the high school students in our district. So if we're thinking all high school students, 1,000 is definitely less than 1/10 of that. So what does this whole within 3 percentage points mean then? Well, within 3 percentage points means it can be the true value, 0.65, or it can be up to 3 below, so 0.62, or 3 above, so 0.68. So that would leave you with a lower bound of 0.62 and an upper bound of 0.68. So I take my true value and I subtract 3 percentage points and I add 3 percentage points. Any sample value within those two numbers would be within 3 percentage points of the true value. So how do we calculate the percentage? Well, this guy is a sandwich, so that's this situation. If you calculate the z-scores for the lower bound and the upper bound, you get a -2 and a +2. And in order to find that middle percentage, you take this probability, so the probability of your upper bound, and you subtract the probability of your lower bound. So this is the probability of z less than 2, and this is the probability of z greater than 2. Okay, so I said that wrong. This is the probability of z less than 2, -2. If this is confusing you, I would go back and look at how you calculate percentages for a normal curve. I think that that would resolve some of the issue. Okay, so then we formalize our statement. the probability that a random sample selected by the company will result in a p-hat within 3 percentage points is about 95%. So the chances are very high that we will be within 3 percentage points of the true value anytime we take a sample, a random sample. Now the last up is our multiple choice, and there is one that's particularly challenging. I'll spend a little bit of time on that, but the other ones hopefully were pretty easy for you. So we have the magazine Sports Illustrated asked a random sample of 750 Division I college athletes. Do you believe in performance-enhancing drugs are a problem do you believe they're a problem in college sports? Suppose that 30% of Division I athletes think that these drugs are a problem. Let p-hat be the sample proportion that say they are. So we have a random sample of 750, so that means n is 750. And they're telling us that we have a true p of 30%. Which of the following are the mean and standard deviation of the sampling distribution of the sample proportion? So that's this thing. Your mean is always centered at the true value, and your standard deviation is, sorry, I don't know why I put 20. 0.30 times 0.70 all over 750. So it's this portion of our problem that they're asking us to find. I calculated that to be letter A, alpha. Okay, this is the one that takes the longest amount. So they're saying decreasing the sample size from 750 to 375 would multiply the standard deviation by, and then you choose the following. So the first thing to decide is, well, how much did we decrease by? We cut our sample size in half. So 750 divided by 2 is 375. So we cut our sample size in half. Okay, well, up here, I have that the standard deviation of p-hat of the original sample is equal to this. Okay, well, sigma of the new sample looks very similar. 0.3 times 0.7 over 750 divided by 2. Here's what I'd like you to notice. This and this are the same. So I can rewrite this as sigma sub p-hat over 2. Because I know that 0.3 times 0.7 divided by 750 is sigma sub p-hat. So I'm replacing all that with sigma sub p-hat and then keeping the divide by 2. Okay, well, just based off of what I know from my math classes, this is the same as the root of sigma sub p-hat. Oh, I'm lying. I gotta break this up first. Sorry, guys. Okay, I'm recognizing that these are the same. So I'm going to use what I know from my math class to separate this radical. And I know that I can rewrite this as 0.3 times 0.7 over 750 and root 2. So I can separate this radical as what I have in yellow, so radical what I have in yellow over radical 2. That's just a mathematic law or principle. And now I can replace this whole thing with sigma sub p hat over root 2. Well, this is the same as 1 over root 2 times sigma sub p hat. So decreasing the sample size from 750 to 375 would multiply the standard deviation by delta. We'll get into this more. We'll have a problem that'll make this slightly easier. But for now, just make sure that you understand my reasoning going through, but you don't necessarily need to memorize this or remember how to do it. The most important thing is that you understand how I get from the sigma sub p hat to the new sigma. Okay, I just want to make this clear really quick. In math, so I should say this. In math, if you had a fraction that was like 2 over 1/2, you could rewrite this as 2 over 1 divided by 2. Like, you can manipulate where the fraction line is if you have like them stacked like this. So when I had 0.3 times 0.7 over 750 divided by 2, I just changed it so that it was 0.3 times 0.7 over 750 divided by 2. So you can group these two however you want. So this is the same as this. So this is the same as that. And that's how I was able to change the standard deviation. The only thing that, well, not the only thing, but one other thing that complicated it was the fact that this root was there. And I know that if I have root a over b, that's the same as root a over root b. I only know this because I'm a math teacher, so I'm not expecting you to remember all this. All I'm expecting is that the reasoning, that you understand, like I said, how I'm getting from here to here. Okay, the sampling distribution of p. So the sampling distribution of p hat is approximately normal because, well, I'm just going to remind myself what condition I need to check for a normal distribution, and that's my large counts. So the only thing that matches large counts is B, as in boy. And then lastly, in a congressional district, 55% of the registered voters are Democrats. Which of the following is equivalent to getting a probability, equivalent to the probability of getting less than 50% Democrats in a random sample of 100? So this is P, this is P hat, this is N. Well, remember to calculate our Z for a proportion is this formula. So we're looking for 0.55 minus 0.50 in the top of our fraction. So 0.55, it's not A because it's got to be 0.55 minus 0.50. So then it's not B, and it's not D. So now we need to choose between Charlie and Echo. Okay, next up is, that's all got to be over standard deviation. But then we got to remember that standard deviation is this formula, which means I need to have a root in the bottom of my fraction. Okay, these both have a root. And then I need to have 0.55 times 0.45 over 100. Well, that has to be Charlie, because Echo is 100 times the proportion. We need 100 divided into the proportion. Okay, so this is my actual key for the multiple choice. And I just made a note on number 6 that this is one thing that's not in the notes but needs to be understood or studied for the exam. So this is kind of a lie. I address this in the next note sheet. So hopefully this will make more sense once we do that. But we didn't have like a whole page on this. So I wanted to make sure that I noted, you will see questions like this even though I didn't devote a whole page to it. Okay, please mark anything that you need clarification on, and allow me to answer questions for you in class next time. If you're a distance learner, please email me or come in and see me anytime that's convenient. Okay, love you guys.